The global economy is rapidly reorienting around artificial intelligence and data science. Yet, in many classrooms, we are still relying on theoretical textbook models to teach concepts that demand hands-on, physical interaction. This disconnect is exactly what recent national directives aim to solve. The NEP 2020 and NCF 2023 frameworks require a direct shift away from rote content memorization, focusing instead on the acquisition of demonstrable, competency-based skills. Similarly, educational boards like the CBSE are mandating that schools embed algorithmic problem-solving and hands-on, project-based learning into their core curriculums to build genuine digital literacy. But achieving this mandate on a practical level presents a challenge. Simply dropping a row of standard computers into a room doesn't automatically generate these core competencies or provide a clear path to professional software development. True alignment requires a highly structured, integrated ecosystem. Nitai AI labs provide this precise structural bridge, transforming abstract educational requirements into a physical space where students can actually build and test real-world applications. Building that bridge starts with the AI Learning Roadmap. This diagram outlines a progressive framework designed to guide students from early childhood all the way through their senior secondary years. The journey begins with foundational play-based logic using tools like Microbit. By middle school, students transition to intermediate platforms like Arduino and Raspberry Pi, gaining hands-on exposure to connected Internet of Things sensors and basic automation. This careful pacing sets the groundwork for the advanced high school years, where students take on rigorous programming in Python, train machine learning models, and navigate complex computer vision tasks. A robust curriculum requires physical infrastructure to support it. We must look at the second layer, the specialized architecture of the lab itself. Processing large datasets and training algorithms demands serious computational power. This means equipping the space with high-performance RTX workstations and centralized enterprise-grade servers to scale heavy data loads efficiently. Beyond the screens, the architecture must include dedicated fabrication spaces, robotic suites to build mechanical prototypes, 3D printing zones for hardware engineering, and testing grounds for sensor networks. When you pair a structured, multi-year curriculum with these specialized physical zones, you change the daily reality of the classroom. Students stop reading about emerging technologies and begin actively engineering them. But high-end workstations and lesson plans yield zero results if teachers aren't equipped to utilize them. This chart illustrates the crucial third layer, the annual certification roadmap for educators. Teachers start with the foundations of AI literacy and data privacy, move into classroom integration, and ultimately achieve mastery in implementing generative AI tools. Advanced training allows educators to move away from standard lecturing. They facilitate student innovation projects, offering technical guidance while students lead their own research and development. These projects reflect high-level practical outputs. Students are leveraging connectivity to design smart city infrastructure, implement precision agricultural technology, and build medical diagnostic prototypes. Focusing on domains like healthcare AI and smart city solutions creates a path for startup incubation. The lab provides the specific high-performance computing and fabrication tools needed to refine a technical prototype into a functional business model. Executing an ecosystem this comprehensive within an active school requires precise logistics. To prevent operational disruption, deployment is managed through a strict 7-step implementation roadmap. Deployment begins by assessing current systems, designing technical architecture, procuring components, and executing physical installation. Then, focus shifts to operational readiness. We conduct user workshops, officially launch the live systems, and provide ongoing maintenance to ensure long-term stability. Crucially, this infrastructure is highly adaptable. The entire ecosystem is designed to scale dynamically, fitting the specific size and budget of different institutional needs. Here, we see the specific tiered investment options. A school can initiate its integration with an essential starter setup at 5 lakh rupees, or scale all the way up to a 1 crore AI center of excellence equipped with end-to-end enterprise infrastructure. By consolidating the curriculum, the specialized hardware, the software platforms, and comprehensive teacher enablement into a single structured operation, Nitai AI acts as a complete integration partner. Schools integrating this blueprint equip students with technical mastery to move beyond basic software use and begin building the core systems of future digital industries.